Hello students, up till now we have covered the point related to 7 crystal systems, and I have shown you a table related to 7 crystal systems. It is again mentioned it here, as we have seen that there are 7 crystal systems when we try to organize atoms in three-dimensional space, and these are cubic, tetragonal, orthorhombic, rhombohedral, hexagonal, monoclinic, and triclinic. In last lecture, we have also seen what is the relation between the lattice parameters of these systems and one or two examples of them. Today, we are going to see what are the Bravais lattices which are related to these crystal systems. In our previous lectures, we have also seen what is unit cell and what are the types of unit cells. Do you remember? Let's revise the same. Unit cell is the basic building block of any crystal structure, and it is classified into two basic types, primitive and non-primitive unit cell. Primitive unit cell is a cell which consists of atoms present at 8 corners of the unit cell. And non-primitive unit cell is a type of unit cell which consists of 8 corner atoms, and along with these 8 corner atoms there are extra atoms which are located in the interior of the unit cell. Again, these non-primitive unit cells are classified into body centered, base centered, and face centered. We have also mentioned the letters to assign these cells. Suppose I want to assign a primitive cell, then I will use capital P. If I want to mention base centered unit cell, I have to write capital C. Then face centered is denoted with capital F, and body centered is denoted with capital I. Today we are going to see the number of ways in which a cubic system or a tetragonal system, orthorhombic system, and remaining systems can be presented in three-dimensional space. If we follow these types of unit cells, then we will observe that there are total 14 ways to represent these 7 crystal systems in a space, and all these arrangements are called as Bravais lattices. One by one, we will see the Bravais lattices present in various crystal systems. First crystal system is cubic crystal system. We know that in case of cubic system, A is equal to B is equal to C, and alpha is equal to gamma is equal to beta is equal to 90 degree. And there are three types of cubic crystal systems were observed. First one is primitive. It is denoted by capital P, or it is named as simple cubic. Body center, it means that there will be 8 corner atoms, and along with that there is an extra atom which is located at the center of unit cell. And face center unit cell, there are 6 extra atoms which are located at the center of respective 6 spaces of the unit cell, and all three types, that is simple cubic, body centered cubic, and face centered cubic, are named as Bravais lattices for cubic systems. Now moving towards tetragonal system. In tetragonal system, if we going to arrange the tetragonal system by considering its condition, that is A is equal to B not equal to C and all angles are equal, we can have two combinations as shown in figure. First one is simple tetragonal. It means that it will have points at the corners of the unit cell only, and body centered tetragonal, it means that there will be an additional point which is located at the center of tetragonal, and these two are called as Bravais lattices corresponding to tetragonal system. The next type is orthorhombic crystal system. In case of orthorhombic crystal systems, when we try to represent this crystal structure, then we will have all four types of presentations. That is, we will have a simple orthorhombic, body-centered orthorhombic, face-centered orthorhombic, and base-centered orthorhombic. Base-centered orthorhombic is also called as end-centered orthorhombic. As I have already mentioned that simple orthorhombic is represented by capital P, body-centered orthorhombic by I, end-centered orthorhombic by C, and face-centered orthorhombic by capital F. Therefore, orthorhombic crystal structure has four types of Bravais lattices as shown in figure. The next is monoclinic crystal structure. Monoclinic crystal structure will have two types of Bravais lattices. One is simple one, that is atoms are situated at the corners only, and another one is base centered. It means that there are extra two atoms which are located at the center of base. And remaining crystal systems, that is rhombohedral, hexagonal, triclinic, all these are having simple structures. It means that we will have a simple rhombohedral, it is denoted by capital P, simple hexagonal denoted by capital P, simple triclinic by capital P. Thus if we count all these arrangement of unit cells in a three-dimensional space, then 7 crystal systems will give us 14 different Bravais lattices. Have you understood? So, 7 crystal systems will give us 14 different Bravais lattices. Thank you.